Hello folks. In the previous session, we had an overview of the Executors framework. In this session, we will discuss about some important interfaces and classes that frequently appear while using the Executors API. The first one is the executor, which is the main interface in this framework. Its main purpose is to decouple the task submission step from thread creation and running steps. It has only one method, void execute, that takes a runnable as a parameter. Executor service is the second most important interface in this framework, and it extends the executor interface. It provides a life cycle to the executors, that is, it provides for an initialization phase, a service phase, and a destruction phase. In the initialization phase, it allocates the required number of threads and starts them too if required. This phase is usually hidden and you can just customize it by providing it some parameters through executors class that actually bootstraps the service. In the service phase, it provides its services by running the submitted tasks. In the destruction phase, it shuts down and stops accepting new tasks for running. The box on the right shows some of the methods provided by the executor service interface. The top two methods are the service methods. These two overloaded methods accept a callable and a runnable respectively and run them. We already know about runnable. For Java newbies, regarding the callable, we call a task by implementing the callable interface when we want that task to return a value. A runnable, on the other hand, does not return any value. Also note that as the executor service extends the executor interface, the execute method is also available for use here. Now, the last three methods shown here cater to the destruction phase. With the shutdown method, you can instruct the service to shut itself down. After this method is called, no new task can be submitted to the service for running. Whatever tasks were being executed by the service will keep running till finished, and whatever tasks were pending to be executed will still be executed. Only new tasks will not be accepted. If you try to submit a new task to the service after shutting it down, obviously you will get an exception. The shutdown now method, on the other hand, is a little unforgiving. It attempts to stop all the actively executing tasks and also halts the processing of all waiting tasks. It also returns the list of pending tasks that had not yet been run. You can check whether the executor service has indeed shut down or not by calling the isShutdown method on it. The next entity in this slide is the executors class. It is a factory class that constructs and returns various kinds of instances of the executor service with commonly useful configuration settings. As is clear from the methods shown on the right, the returned executor service instance can act as a fixed thread pool or a cached thread pool or even as a single thread executor. For creating an executor service backed by a fixed thread pool, you call the new fixed thread pool method. It takes an integer parameter named n threads that specifies the number of threads that you want in the pool. This means that at any time, at most n threads number of tasks can execute concurrently. Let me give you an example. Suppose that we have specified the value of n threads as 5. That is, we want 5 threads in our pool. Then this means that at most 5 tasks can execute concurrently. If we submit, say, 20 tasks to this pool, then the first 5 of them will start executing immediately in parallel, while the rest of the 15 tasks will be put in a tasks queue. Whenever any of the 5 threads finishes execution of the task that it was executing, it becomes available. It then checks if there is any task awaiting execution in the tasks queue. If there is, it takes the next task from this queue and executes it, and so on and so forth. but the number of simultaneously executing tasks will never exceed 5 here. You can also create an executor service backed by a cached thread pool by calling the new cached thread pool method. This kind of executor service continues creating threads as long as no thread is available and there are still some tasks awaiting execution. Once a thread is done executing a task, it is reused. If a thread is available when executing a task, then that thread is used instead of creating a new one. For example, suppose that we have submitted 20 tasks one by one such that none of the tasks finish executing at least till all the 20 tasks have been submitted. Then this kind of pool will create 20 threads for running those 20 tasks. If we submit 5 more tasks and none of the previous 20 tasks have finished executing, then 5 more threads will be created to execute the newly submitted 5 tasks, thereby making the total number of threads and tasks as 25. Now suppose that 4 of the 25 submitted tasks have finished execution. This means that 4 threads are now available. If we submit 5 more tasks now, then 4 of them will be executed by the 4 available threads and 1 new thread will be created for the 5th one. So theoretically, there is no upper limit as to the number of threads that will be created by this kind of executor service or pool. Such a pool is useful for scenarios where a large number of short-lived asynchronous tasks are to be executed. After the cached thread pool, let us now discuss about the single thread executor. Sometimes you need a background thread that should execute tasks one by one from a queue but should never execute more than one task simultaneously. For example, Java Swing's event dispatch thread has such a requirement. It has to process and dispatch UI events one by one from a queue. For such requirements, there is the single thread executor. It can be created by calling the new single thread executor method of the executors class. It guarantees that all the tasks will be executed sequentially only, and no more than one task will be active at any given time. Similar to the single thread executor is single thread scheduled executor that can be created by calling the new single thread scheduled executor method. It creates a single threaded executor that can schedule tasks from a queue to run one after the other after a given delay or to execute the tasks periodically from a queue. After knowing about all these executors, one thing worth mentioning here is that all the executor services After knowing about all these executors, one thing worth mentioning here is that all the executor service instances returned by the executors class are actually objects of a class called threadpool executor. Threadpool executor implements executor service interface. Different kinds of thread pools are constructed by passing in different configuration settings to the constructor of the threadpool executor class. Knowledge of this class is not required for using the executors class or for even using the executors framework at all. You only directly need to work with threadpool executor in rare instances when your application's needs cannot be fulfilled by the executor service instances provided by the executors factory class. So just keep it at the back of your mind that if you need some custom thread pools, then you can create them by tweaking the thread pool executor class. The last entity in the list on this slide is the future interface. Whenever you submit a callable for execution, the executor service returns you an instance of future. You can call the get method on this future instance to get the value returned by your callable task. The call on this get method gets blocked till the task has run to completion and has returned the value. Future also provides isDone method for checking if the task has run to completion as yet or not. Now, as discussed already, There are many types of pre-tweaked thread pools provided by the JDK out of the box. In the upcoming videos, we will look at each of these thread pools in action one by one, except the scheduled executors, which we will look at in another section later. We will also see the classes depicted on the previous slide in action in the upcoming videos. That's all on the topic of important classes and interfaces in Executors framework. See you in the next video now. Till then, take care and bye-bye.